So let's discuss the solution to this question 1b. So we'll have the first step is to work out the reduction formula for sine power nx dx. Now, this is really application of integration by parts, but we have to rewrite the integrand so that we can easily pick out u and v that is going to help us get the desired formula. So note that when we write sine power nx is the same thing as writing sine x power n. That's what this statement means. So we can rewrite this as sine power nx is the same as sine x power n, which is the same as sine x power n minus 1 times sine of x, psi power 1. So that this integral will be integral of sine power n x dx equals to integral of sine power n minus 1 x times sine of x and then dx. There's no miracle you have performed with the same integrand, because when you multiply sine power n minus 1 x times sine of x, you still get sine power nx. Now, once you have done this splitting or rewriting the sine power nx, then we let this part to be u and then this other part to be dv. So let u to be sine power n minus 1 x and dv to be given by sine x dx. Now, remember when we say sine raised power n minus 1 x is the same thing as saying sine of x power n minus 1. So to get du here, we use differentiation by chain rule. So drop the power, we have n minus 1, subtracting 1 from the power, so we get sine power n minus 2x. And then now differentiating inside the sine function, we get cosine of x and then dx. And to get v here will be the integral of sine x dx. And we know the integration of sine function is negative cos function. So we have a u, we have a du, we have dv, and then we have v. So integration by parts formula is integral of u dv is uv minus integral of v du. So which means that the integral of sine power n x dx is the same as uv, this is v, this is u, so I'll have negative sine raised power n minus 1 x times cosine of x. The negative sign comes because v is negative cos of x. And then minus integral of v du. Now our du is this value and our v is this negative cosine of x. So because we have a negative sign here, then this negative and this negative in the formula will cancel to give a positive sign. And so we'll have also n minus 1 is a constant, so which can always be written outside the integration sign. So we'll have n minus 1 integral of sine power n minus 2x. This cosine times this cosine will give us cos squared x and then dx. Then we also know that cos squared x is the same as 1 minus sine squared x. So we are going to make use of this identity to rewrite this part so that we have integral of sine power n x dx will be negative sine raised power n minus 1 x cosine of x plus n minus 1 integral of sine power n minus 2x into, so this will be 1 minus sine squared x, and then dx. So we are going now to multiply this factor n minus 1 to each of these functions in this integral sign, so that we'll have integral of sine power nx dx equals to negative sine n minus 1 x cosine of x plus n minus 1. Now multiplying this sine raised power n minus 2x times 1, we get integral of sine n minus 2x dx. And then this negative sign here, so I'll have a minus n minus 1 integral of n. Remember, this is sine and this is also sine. So it's like I have sine x power n minus 2 times sine x power n power 2. So using laws of indices, we'll have sine x power n minus 2 plus 2. So minus 2 plus 2 cancels out. So the power is just n. So we'll have sine power n x dx. Now you see the last term in this integral on the right hand side, in this equation on the right hand side, had the same integral value as what is on the left. So bring this to the left, this sign will be positive, and so I'll have integral of sine power nx dx now plus n minus 1 integral of sine power n x dx equals to negative sine raised power n minus 1 x cosine of x plus n minus 1 integral of sine power n minus 2 x dx. So this coefficient of this one is 1. So I'll have 1 plus n minus 1. And then what is common is the integral of sine power n x dx, which will give negative sine n minus 1 x cos of x plus n minus 1 integral of sine power n minus 2x dx. So n, this part here, when you open the brackets, we'll have 1 plus n minus 1. 1 and minus 1 cancel, so we get just n. So we'll have n integral of sine power n x dx equals to negative sine power n minus 1 x cosine of x plus n minus 1 integral of sine power n minus 2x dx. So to get this integral, we simply divide through by n. So dividing here by n, it's like multiplying both sides by n. Then this and this cancels out, so that integral of sine power n x dx will be negative 1 over n sine raised power n minus 1 x cosine of x plus divide by this coefficient n minus 1 over n integral of sine power n minus 2 x dx. So this is the required reduction formula. Now, the next step is now to use it to find the value of the integral of sine power 4x dx. So integral of sine power 4x dx, here n is 4. So will be given by -1/4. 4 minus 1 is 3, so sine power 3x cosine of x plus 3 minus 1 is 2. 4 minus 1 is 3, and then over 4, integral of sine 4 minus 2 is 2 x dx. Let's call this one equation 1. Now, in equation 1, we have also to define the integral of sine squared x dx. Now, in this case, n will be 2. So we have -1/2, and then 2 minus 1 is 1, so just sine of x, cosine of x, plus 2 minus 1 is 1, and then over 2, integral of 2 minus 2 is 0, so sine x power 0 is 1, so this is just dx, which will be -1/2 sine of x, cosine of x, and then plus 1/2 x. Remember, integral of just say 1 dx is given by x. So if I call this one, I say plus c naught 2. So using 2 in 1, we get that the integral of sine power 4x dx will be given by -1/4 sine power 3x cosine of x plus 3/4, and then this part from 2 is -1/2 sine x cosine of x plus 1/2 x, and then plus c naught, constant of integration. Simplifying, we'll get -1/4 sine power 3 x cosine of x minus 3/4 by this is 3/8 sine of x cosine of x. This by this will give us plus 3/8 x, and then plus 3/4 c naught. Remember, c naught is a constant. When you multiply it by 3/4, you also get a constant. And so, therefore, the integral of sine power 4x dx is -1/4 sine cosine x minus 3/8 sine x cosine of x plus 3/8 x, and then plus c. So where this c is this constant 3/4 c naught. So this was the required result for that particular question. Thank you.